Good afternoon, everyone. My name is Naufal Anwar Faras, and today I would like to present to you the term project for my big data analytics. So let's get started. My project is about making a simulation of PID step response plot tuning along with examples using Wolfram Mathematica. So the focus chapter would be in chapter 3, which is interactive visualization. So where's the data from? The type of data here used is tabular data. The parameters used here are KP, KI, KD, time in seconds, and output response. The data is typed in manually in Wolfram Mathematica. Calculations are also done in Wolfram Mathematica. Let's move on how the program works. So here are the 8 parts of the core components of my program. And this part is the first one, which is the initialization. And this one starting on the manipulate parts. And this one also still part of manipulate, this two, and also this one as well. And lastly for this one, since calculations are done directly in Mathematica, it is imperative to use these two sets of programs to prevent unnecessary lags. So you're going to need continuous action false and safe definitions true. Why? Well, you see, these sliders when moved would immediately trigger Mathematica to perform calculations, regardless whether you're done moving it or not. This causes severe lag issues when performing calculations. So yeah, here is the result of my program. You can see here there are 2 tabs, tuning and example, and this one is on the tuning. And you can interchange it to 3D plot as well. And here, if we interact with the 3 sliders, KPK and KD, you can see that how the plot responds to the changes. And here is when it maxed out and it reaches a stable state. This one and the next part is basically the cosmetics of the tuning tab. And let's move on to the example tab. The example tab has 3 states: stable, overshoot, and undershoot. And of course, it can interchange to 3D plot as well. So how's the outcome? Well, here are several things that I discovered. Well, the first one, calculating transfer function takes a long time. Secondly, pre-calculating the output response will eliminate the loading time. There is a false optimum appearing in the plot. Supposedly, the output response value should be as close as possible to 1. The stable condition does not require absolute perfection to be called stable. Lastly, the 3D plot can be useful to visualize how the system responses when KP, KI, and KD change simultaneously. That is all from me. Thank you very much.